7.2 Scalar Multiplication. Our learning intention: how to do scalar multiplication of matrices and our success criteria. I can do scalar multiplications with matrices by hand and with CAS. Now in this video, I'm not showing you any CAS instructions. I'm going to leave that for a separate video. This is purely just the method by hand. So scalar multiplication involves multiplying a matrix by a number. When dealing with matrices, the word scalar is used to indicate a number that's not in a matrix. So it's going to be the number on the outside. To multiply matrix A by the scalar 4, simply multiply each of the elements in matrix A by 4. So we have matrix A, and we want to multiply 4 by A. Make my 4 really clear. There we go. So what I do is I put a 4 outside of my matrix, which is 5, 2, 7, minus 3, 12 and 6. Now this guy here is my scalar. He's the one I want to multiply by. Multiply with A. And then all I do is I take each element, I go 4 times 5. So it would be 4 times 5. Then I take the next one, which is 4 times 2. I keep them in the corresponding positions as to what they are sitting in matrix A. So the 5 stays in position A1, A11, the 2 stays in position row 1, column 2, A12. Have to think about that one. So then I do 4 times 7, 4 times -3, 4 times 12, and 4 times 6. So all I've done so far is multiplied this 4, the scalar outside, by each of the elements. 4 times 5 is 20. You'll note that it still ends up sitting in exactly the same spot. So at the moment it was in A11, 4 times 5 is in position A11, and number 20 is in position A11. It doesn't move. 4 times 2 is 8, 4 times 7 is 28, 4 times -3 is -12, and 4 times 12 is 48. Finally, 4 times 6 is 24. So, if A equals 5, 2, 7, minus 3, or -3, 12 and 6, 4A is equal to 28, 28, -12, 48 and 24. So I've taken each of the elements and multiplied them by 4 because that's what my scalar was. All right, next slide. So this is a pretty quick video today, just to run through how to solve scalar problems. Find the values of the pronumerals in the following matrix equation. So perform the scalar multiplications on the left-hand side. So what we're going to do is we're going to use this guy here and this guy here and perform them first. So we have 3x to -1 plus 2, 4, 5y. And all I do is I multiply through with the scalar that is on the outside of that particular bracket. So the 3 only corresponds to the first matrix, and the 2 will only correspond to the second matrix. They don't sort of cross over with each other. So 3 times x is 3x. 3 times 2 is 6. 3 times -1 is -3. And I put my brackets back around that. Then I put my plus sign, and I've got 2 times 4 is 8. 2 times 5 is 10. 2 times y is 2y. And my brackets again. So now I can add the corresponding elements. So what I do is I take the first of both and I add them together. And I end up with 3x plus 8. Leave a little bit of space as I would in the other matrices. 6 and 10 is 16. -3 plus 2y is my last element. So bear in mind that, or take note that they're still sitting in exactly the same position. So 3x and 8 were both in A11 and they are still sitting in position A11. So we're going to take this, this matrix and we're going to pop that on the next slide. What have we got? 3. We'll be flicking back and forth a little bit. So we've got, so far, I've got 3x plus 8, 16, and minus 3 plus 2y. There we go. So it says take the answer in the previous step and equate it to the right-hand side of the original equation. So that just means put an equal sign and take this guy here. 14, 16 and 11, put brackets around him, done. So now I've equated to the other side. And the next step after that says equate corresponding elements and solve for the unknown pronumerals. So the pronumerals that we're trying to find are x and y. So what we do is we take 3x plus 8 and the corresponding element in the other matrix, also in position A11, is 14. So 3x plus 8 equals 14. And working through, I'm going to change colours here. So if I was to take 8 off that side and take 8 off that side, I would end up with 3x is equal to 6 and x is equal to 2. So if I was to fill the gaps here, I would end up with 2 in the place of x. And then I go forth and do exactly the same thing and solve for y. Make that green. So I take my equation there, and then the corresponding element is 11 at the end. So I've got minus 3 plus 2y equals 11. And I'm going to get rid of that 3, so I need to add 3 to both sides. So I end up with 2y equals 14 and y equals 7. So then looking at the original equation again, where the y is, that would be the number 7. We can double check both of these solutions as well by doing 3 times 2 is 6, 2 times 4 is 8, 6 plus 8 equals 14. Our x value is correct. Give the problems a go and I will meet you back for 7.3.